Welcome to this episode of the Structural Engineering Channel podcast, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives.
In this episode, we are talking to Emily Galliamo, the past president of the National Council of Structural Engineers Association and the Structural Engineers Association of North California, about building safety in response to the recent building that collapsed in Miami a few weeks ago. She will also talk about a structural engineer's role post a collapse and how it will affect our building codes.
I'm your co-host, Matt Picardal.
And I'm your co-host, Kara Green. Now let's jump into our conversation of the week with Emily Galliamo. All right, Emily, welcome to the show. We're so happy to have you here. Now, in your own words, keep in mind, we've just introduced you, but in your own words, can you tell us, our listeners, a little bit about your history with working with NCSEA and SEAONC?
Sure. I guess I'd first just say thank you so much for having me here today. It's my pleasure to have the opportunity to chat with you all and hopefully reach a broader network of structural engineers and maybe even the broader community. My involvement at NCSEA started a little over a decade ago, where I attended my first conference as a young member on a scholarship, our first ever scholarship being offered through NCSEA. And at that point, there wasn't a big network of other young members at NCSEA. And so I helped launch what's now called the NCSEA Young Member Support Group. And so it's a group that really helps facilitate and support young member committees all over the nation through local SEAs. So that was kind of my first taste at NCSEA. I've made my way through chairing the communications committee. I'm currently chairing our wind committee at NCSEA, and I have just on the tail end of a 7-year commitment to the board of directors and finished my term as president about 6 months ago. To be part of NCSEA, my local SEA is SEAONC, as you said, or SEONC, we affectionately call ourselves, the Structural Engineers of Northern California. And I've done the leadership track there as well. And I'm actually currently serving as past president of the Structural Engineers Association of Northern California.
Thanks for that, Emily. We wanted to talk to you about building safety, and could you touch on the recent building collapse in Miami? You know, as a structural engineer, what was your first reaction to that?
Yeah, I guess just as a human being, and then even more so as a structural engineer, my first reaction was just heartbreak. Clearly, this is an extremely tragic event, and as a structural engineer, it's an event that affects us not just professionally, but also personally. And it really, it affects us emotionally. And I'll say my thoughts immediately were with the affected families, with the search and rescue teams. I will tell you, NCSEA, we were actually in a board meeting. It started at 7 a.m. the morning right after the collapse. And throughout the meeting, we started to field different media requests for interviews. And as a leadership group, we really paused and we asked ourselves, is this the right place for us to be speaking? We are really a national organization. We were not, none of us were located in Florida. Obviously, none of us had seen the collapse firsthand. But we decided as a group, it was actually really important for us to field questions from the media, from the public, to be proactively engaged, to hopefully be a balanced voice, urging patience. And so as a group at NCSEA, we've worked through that process of shock and ultimately trying to offer support to the structural engineering community and the public at large.
Thank you for that. And that's actually an interesting point to make, because I think everyone in the community, the engineering community, got those questions. You know, I know as an engineer, I had like my family call me and they were like, what do you think actually happened? How does that happen? And I was like, I can't answer that. I don't know. I'm not an engineer in Florida who built that building. So it's instead of reacting, I appreciate y'all kind of taking a pause and giving an appropriate response to the public, because there was so much shock, not only internally in the community, but also externally, because that was a condo building, like an existing condo building for, since I think the 1980s. And it caused a lot of concern with the public for sure. But speaking on that, Emily, can you explain to our listeners what a structural engineer's role is post-collapse? Because obviously we're involved in the pre-design, but what is our involvement post-design, especially when there is such a tragedy that happens?
Yeah, I think we forget, but the first role of a structural engineer in this case is actually to help assist in the search and rescue operations. We want to make sure that our first responders are working through the safest possible conditions, whether that's shoring, or in this case, we have to remember there was still a portion of the building that was still standing. So structural engineers were on call to make sure that those temporary conditions were as safe as possible for the search and rescue teams. That was compounded, we know, with a hurricane that was coming. So there were a lot of engineers, I think, involved in making sure that we were creating an environment that ideally could lead to rescue of any survivors and then ultimately the rescue operations. After the search and rescue piece, we get to the, let's say, forensic piece. And this is the one everyone jumps to immediately. The phone call you just alluded to, what happened? And I think we need to remember that forensic and that technical investigation into the cause is something that takes a long time and will take a long time. And I'm sure we'll talk a little bit about more here today. And once that forensic or technical investigation is complete, then a structural engineer will be very much involved in if we need to make changes. Do we need to make changes to building codes? Do we need to make changes to how we permit drawings? Do we need to make changes to the construction quality assurance process? Do we need to make changes to how we maintain our buildings over their lifespan? Do we need to make changes to licensure requirements? So absolutely, structural engineers have a really key role: search and rescue, investigation, and then post determination of what happened in making changes to ensure that this doesn't happen again.
Yeah, thanks, Emily. I know it's, I talked to attending some of those SEOC organization here in, at least in SoCal, got a chance to hear some of the presentations from first responders. And yeah, that's, I think kind of like what you said too, is, it's a tragedy first. I mean, and I think sometimes engineers, especially if you're not part of that project, they might just tend to focus on the buildings, like, oh, what will happen to the building collapse? But a lot of it, from what I hear, if you're a first responder, you have to have that mindset shift of it's not, it's not just a building collapse. A lot of really a tragedy of people lost their lives, and that's not the time to be asking questions about why did it fall. It's a time to help out those who need help, and yeah, much respect to those, that the first responders, even the structural engineers that went on there. I think that's so important. Kind of alluding to that with this next question, because I've always wondered how, I guess, what do you think the best way is to respond to this? Because we always get that question, just like Carrie just said, like, hey, what do you think caused the building collapse? Like, are we allowed to? Because for me, I was like, well, I guess like this could have happened, but I have no idea. There's so many things that could have gone wrong. You see all these articles on the internet. Like, do you have a response to when people ask you what caused the building collapse? Or do you have any advice for structural engineers in general when something like this happens, on how to respond to that?
Yeah, for sure. You just alluded to it. I think every engineer listening to this podcast has probably been asked this question. And each of us individually, I'm sure, has heard or even come up with maybe our own possible causes: design issues, construction defects, corrosion. But I would remind us that it would frankly be irresponsible for us to speculate on these causes before a review is complete. What I do think we can probably say with some confidence is that it's very likely that it wasn't just one cause of the collapse, but likely several compounding factors that led to the collapse. So I would say, in terms of what do we respond as a profession, I think it's really important as a profession that we don't jump to conclusions, that we don't publicly speculate on what may have caused the collapse, not to sensationalize, rather just speak on facts. Speak on the role and the commitment of structural engineers to building safety.
So, and yeah, 100%. I've had to kind of hold my tongue, especially because I did, before I was in this role, I was in geotech, and, my mother knew, like, I worked in Alabama for a long time, and she was like, what could have happened? And I was like, there's a lot of things that could have happened. It's really going to come out a lot later that we'll find out the facts of what actually happened for that to cause a collapse like that.
Absolutely.
But when we have a collapse like this, it causes an earthquake in the community. It's all over the place. Do you see, especially since your involvement in NCSEA, do you see any building code changes coming out of this? Because, the way I looked at the structure, it wasn't necessarily an old structure, but it was built in the 1980s. And I know the codes have already been developed to make quality assurance and buildings, safer since then. But I was curious on your take on that, if there have been any preliminary discussions towards building code safety measures, quality assurance, or what that may look like.
Yeah, I guess in order to say what we're going to change as a result of the collapse, we need to know the cause or causes of the collapse. Was it again an issue of inadequate design or a building code issue? Was it an issue with construction? Was it an issue of maintenance? But I will say, I do anticipate we're going to see lots of changes as a result of this tragedy. And I think maybe a good example to give the profession and maybe even the public some perspective about what this might look like is to go back to another tragedy that happened in my backyard, the Berkeley balcony collapse. And that was also a really sudden and unfortunate loss of life, failure of a structural element. And when you look at the investigation that took place after that collapse, and then ultimately the changes as a result of that event, you'll start to see that it wasn't a single-pronged solution. So for example, after the Berkeley balcony collapse, there have been code changes specifically to the live load capacity requirements of a balcony. So yes, a code change. However, there have also been changes in construction. How do we build a balcony? How do we waterproof a balcony? How do we drain a balcony? So there were changes to really just the actual nuts and bolts of how we construct. And then lastly, and maybe the most important thing that came out of the Berkeley balcony collapse is a requirement that really changes how we inspect these elements. In fact, we call them exterior elevated elements, or EEE elements. They are now required to be inspected over their life. So not just as they're being built, but at certain intervals of their life, we identify these as critical elements. And so they have to be inspected by an engineer. And it's not just an inspection where we go stand underneath and take a picture and say, well, the paint's peeling a little bit, but it has to be an inspection that actually opens up the elements in a way that allows us to inspect the structure and make sure that there isn't any degradation happening. So again, this was a different event, but we saw changes in our codes and how we actually apply loads. We saw changes in construction practice, and we saw changes in inspection. I fully expect we're going to have a similar process take place as we uncover the cause or causes of the Surfside collapse. And we very likely will be seeing changes across our industry and our profession.
Thanks for that, Emily. The structural engineering profession, we don't get too much publicity. Unfortunately, this is, one of those times that we do get publicity. In the public eye, do you have any thoughts on that? Maybe why that is, or do you think that's good publicity, bad publicity, or what do you think about that in terms of the general public?
Yeah, you're absolutely right. I think in many ways, the role of a structural engineer is not well understood because usually what we do is covered up, right? We are the skeleton or the bones of a structure, and the architect will put the skin and the muscles and the makeup on top of a structure. And so ultimately, people don't really see the work we do. But also, I would argue that we do a really fabulous job in the United States with building codes, with design, with construction. And so generally, we don't have buildings fall down, which is actually what makes this particular event so shocking. But I would argue as a profession, we don't do a great job fully celebrating our successes or being intentionally visible when we want to be. And as tragic as this particular event is, it reminds us and it reminds the public that structural engineers, we have a really critical role to play in building safety. And not just building safety, but we see after this particular collapse that building safety is such a huge component in our communities. And so our role in keeping our structures safe is really a vital role in keeping our communities functioning. We live, we play, we work in structures designed by structural engineers. And if these buildings aren't able to stand, whether it's a natural disaster or otherwise, we see it's not just the consequences of a building failure, it's really a community that's affected. There's loss of life, there's loss of income, there's downtime. So I would argue that these tragedies remind us and the public we have a really important role to play in, I'll use the phrase, community resilience. So it goes beyond just building safety. I will put on, just quickly share, at NCSEA, prior to this particular event, we have lamented this lack of public visibility for a long time. And about a year ago, NCSEA committed to a public relations and marketing initiative on behalf of the structural engineering profession. And that initiative is to connect us with the general public, with policymakers, with students, with potential clients, to share the value of structural engineering, and not to wait until these unfortunate disasters or tragedies take place, but rather to control that narrative, to tell our story, and frankly, to, let's say, raise the bar on our structural engineering profession.
I am very excited to hear that, because I've had this conversation, especially with my family and my friends, is like, structural engineers, you only hear about the bad things, but it's very few and far between, but you never hear about all the successes that we have as an industry that, I don't want to say the public takes for granted, but they definitely do. They walk into a building every single day and, it's been up since maybe like the 1800s, because I was working on some projects in Houston that have been built since, 1834. And let me tell you, they were very hard to renovate.
Yeah, I just wanted to add that I really like that part about, construct your own narrative or else other people will do it for you. So I think that's a great initiative.
Most definitely. So with this collapse, of course, there has been discussions, and I kind of alluded to it before, how we have already come so far in innovation, especially with code. And then you touched on the Berkeley collapse. Do you think there will be any new innovations that come about? There's been discussion about, of course, corrosion resistance, or like different types and new types of concrete that are stronger. Do you see that coming about as, a narrative that maybe those types of companies will approach the market with? Do you see that as being a potential solution?
Yeah, I think for sure, particularly as the actual cause or causes of collapse come out, I do think we're going to see some new innovations, or maybe a little bit more of a push on some innovations that have been out there, but maybe underutilized. And that may be about concrete maintenance, repair, restoration. For example, a product or a system that allows for an economically or minimally invasive repair of, let's say, corroded rebar in concrete, or other materials, steel, for example, something that provides more durability, whether it's concrete, steel, or wood. I do think that may become more of a focus after this particular event. I also think we may see new technologies in terms of how we can innovatively do structural evaluations of existing buildings to overcome things we can't see easily. So if we, for example, go on a job site and we see a little spalling of concrete or a little bit of rusting of rebar, it's really hard for us to say exactly how bad it is without doing some major demo. And so maybe there's some technology that is being developed or could be developed that helps us determine that next step that's appropriate after a fairly limited visual evaluation.
Emily, you're in California. How has the reaction been there to this event? Like, have you heard of any regional interests coming from this or developments?
Yeah, absolutely. I guess I'll start with saying, yes, I am from California, but I know through NCSEA's network that almost all of our SEAs regionally have received the same calls from their local news media, which is, what happened? And then, could this happen here? That's really, the question. And it doesn't matter. We've heard it here in earthquake territory. I'm sure the same questions happening up and down the hurricane coastline. We have public that are really concerned about something happening in their communities. I would say we as structural engineers, we're generally more concerned about these types of failures happening as a result of an extreme event, a hurricane, an earthquake, those are the events that were, a little bit more heavy on our minds prior to this particular event. Some of the older buildings, 30, 40, 50-year-old buildings, particularly in the seismic zones that may have some vulnerabilities compared with current code requirements. And we talked about that a little before, that the code has already progressed. Construction techniques already have progressed. But at a high level, I would argue, as structural engineers, we have a captive audience right now. We have, a news media, we have a general public that is interested in building safety right now. And that's something that, in my neck of the woods, we don't normally see except for post-earthquake type of an opportunity. So this is a chance for us as structural engineers to remind building owners the importance of building maintenance, or in my neck of the woods, to remind owners about proactive retrofit options. And specifically, what am I hearing out here? We're getting a lot of questions about, we're hearing the phrase non-ductile concrete. It's an ordinance that some places in the West Coast have already enacted ordinances to try and mitigate that vulnerable building type, non-ductile concrete. So that has become something that, seeing an older building that was concrete collapse in Florida, the common question is, well, is that what we should be worried about here in California? Is that the non-ductile concrete ordinance we're hearing about? So absolutely, we've been fielding calls. Again, we would argue the difference is the collapse that happened in Surfside, to our knowledge, happened under no extreme lateral loading. The vulnerable buildings that we're most worried about here in California may be similar concrete type of structures, but typically under lateral seismic type of loading is where we're more concerned about their performance.
So just to touch on what you mentioned, non-ductile concrete, because I'm from Texas, none of our stuff moves, or it shouldn't. And I know very, very little about seismic, other than I know ductility is a requirement, overstrength factors, those sorts of components, but my knowledge is very, very light. So can you tell me, what exactly is non-ductile concrete? Like, what is ductile concrete? I'm not familiar with that.
Sure. Yeah. Non-ductile concrete's a phrase that we typically use for a building that has, let's say, brittle concrete elements. So ductile, brittle, those are opposites of each other. And those elements can be columns, they can be walls, they can be beams, or even the connections between them. But non-ductile concrete buildings tend to perform poorly during earthquakes because of a lack of reinforcing steel or rebar. Again, if we designed a concrete building today to today's standards, and anyone who has driven down the streets of San Francisco and seen a concrete building go up, it almost looks like a steel wall when you start to see that reinforcement. But that reinforcement is designed to act as a strong cage. It holds the concrete together and intact during an earthquake, and it allows it to then support its own weight after a seismic event. So in a non-ductile concrete building, and those are typically, we tag buildings built before 1980 plus minus, 1980 building codes. We tag those as non-ductile concrete buildings. So they generally lack steel reinforcement that's sufficient to create that confining cage. So then we start to see potentially cracking or crushing. And again, we're worried about collapse post-earthquake. So the question is this what happened in Surfside? Was that non-ductile concrete? I definitely think the ages are similar. The codes they were designed under may be similar. But really, when we're talking about non-ductile concrete out here, we are talking about lateral seismic types of loading. We are not talking about sustained gravity type of loading for failure, for example. Specific to non-ductile concrete, I alluded to, it's a phrase that, depending on where you are in California, whether you're the general public or an engineer, you may have heard, because we do have certain jurisdictions who have enacted ordinances to try and mitigate this known vulnerable building type. So for example, in Southern California, Los Angeles and West Hollywood have some ordinances in place that require retrofits to these known pre-1980s non-ductile concrete structures. The city of San Francisco is pursuing a similar ordinance. And so those are, that's kind of the tie. I will say, I hope that concrete isn't the only one taking a bad rap / seeing an opportunity for retrofit, because depending on the building type, if it's masonry, for example, unreinforced masonry is another vulnerable building type that we would like to see retrofitted. soft stories, wood framed with really open bottom first floors is another known vulnerable building type we'd like to see retrofitted. So steel, concrete, wood, masonry, there's opportunities to improve all of them, but non-ductile concrete is the one that has kind of been the catchphrase post-Surfside collapse event.
Thanks for that explanation, Emily. Before we close out, I wanted to touch upon recertification. That's something that I've kind of heard on the news. I think you got this 40-year recertification. I think it was per the IBC requirements. Could you touch up on that? I wasn't really too sure myself. Like, should it be 40 years? Should it not be? And maybe explain a little bit about that recertification process.
Yeah, it's definitely a hot topic post collapse. It is not an IBC or International Building Code requirement, but rather it was a local jurisdictional requirement. And to my knowledge, it was a requirement that after 40 years, the electrical and the structural systems needed to be recertified. And so not currently an IBC. And ultimately, there are many tiers talking about this opportunity. Let's say whether it ends up being an IBC requirement or probably more likely it to be state or local jurisdictions or agencies that regulate, depending on the age of a building, and frankly, even relevant factors in that region. You can imagine a structure that's right on the ocean, for example, probably has a different type of environment that may lead you to want to formally inspect the building sooner than a building that's maybe located far from the ocean. So absolutely, NCSEA, a lot of our technical committees, a lot of code committees, jurisdictions. Again, I'm hearing LA counties bringing a group together to discuss what a recertification might look like, process might look like. So absolutely interesting conversation. I do expect we'll hear some changes, probably more at a local than a national level. But I would like to just, if I have any building owners listening here, encourage you, we don't need to have a formal code requirement to have a proactive building owner call up a structural engineer and say, hey, can you come take a look at my building? Whether it's because you're seeing some cracking or you're suspecting some movement, or it's the right thing to do. We take care of our cars. We should be taking care of our properties, our homes, our offices in the same manner. So inspections, observations, calling a structural engineer to get on site is a great thing to do, whether or not there is a formal recertification requirement.
That's great. And just to close off again, because I know likely based on the topic that we're discussing, we're probably going to have a lot of listeners, building owners, public, structural engineer, the engineering community. What closing remarks would you like to provide to the public and the structural engineering profession?
Oh, it's a good one. I'll start with the public and I'll finish up with our SEs. So to the public, I guess I would ask to hear me of two things. The first one is I'd like to convey confidence in our building codes, in the role of structural engineers in building safety and any changes moving forward. We will learn from this experience. We will find ways to make changes that will prevent this hopefully from happening again, and structural engineers will play a vital role in that path forward. The second thing, I just alluded to it, but absolutely the general public, I'd love for them to hear the importance of performing ongoing maintenance and evaluations and retrofits to buildings over their life. You know, we design a building to the code at the time of design and construction, but it absolutely doesn't remove the imperative on the building owner to be aware, to maintain their structure, to watch it as it ages, be familiar enough to recognize any signs of distress or potential changes. So it's my general public to my fellow SE profession. We started kind of at the top of the podcast about this, but I would encourage structural engineers to express to the media. We recognize that they want to hear a headline, they want to hear a soundbite, but we need to be patient and allow the investigation the time to happen. We need to speak to the public responsibly, without speculation, without sensationalism. I think it's really important for the profession to speak with a consistent and balanced voice. In the meantime, I think there are things that people can do if they, as a structural engineer, if they are so inclined. I would say find your space, find what makes you passionate. There are opportunities to contribute through we call it SEER committee at NCSEA, Structural Engineering Emergency Response Committee, to be a second responder to evaluate building safety post-disaster, join a local SCA, SCI building code committee and study potential code changes or inspection requirement changes as a result of this event. And then I guess lastly, as structural engineers, let's think about how we'd like our profession to be perceived by the general public, not just when we have these unfortunate disasters, but day to day. And I think making your voice heard, whether that's through the NCSEA PR campaign or through another professional organization, disasters like these, they remind us that while tragic, we do have an opportunity and maybe even a mandate to be more visible. And I truly believe that our role in post-disaster response and recovery can help not just the structural engineering profession, but even our communities by showing our value and our expertise.
Thank you so much. This was such an interesting topic. It's been such a hot topic, unfortunately, especially for us internally. I remember when it happened and I had a meeting that morning as well. And I think for 15 minutes, we all just discussed the things that possibly could have happened. And I was like, there's so many things that could have happened to this building.
Yeah.
It's so unfortunate.
So unfortunate and just bizarre for a 40-year-old building. It's one thing if this thing was under construction, but fortunately, such a rare occurrence that we're really, as a profession, struggling to wrap our heads around how this happens.
Yes. And I've been following a lot of the stories on LinkedIn, and it's interesting to see other professions commentary. And I'm like, no, don't say these things because they're not accurate, or they may not even be accurate. So,
yeah,
and it's hard to.
Yeah, I just wanted to say thanks for, because that's something I've always wondered too. How should we respond? I don't think we should respond with guesses, or because then that stuff will get misquoted by the media for sure. You'll see all these articles, on the internet that are kind of just speculation at this point, and no one really knows. And I guess, people just start blaming each other, and no one's even got the facts straight. So
and I'll say, as a structural engineer, we are not trained to sit in front of the media and know how to say the right things. And so I think our natural intuition is to say pass. I'm not in Florida. I don't know the cause. But, in some cases, silence from our leadership is almost as hurtful as speculation, because if our profession doesn't have a voice that is urging patience and avoiding speculation, then the media is going to go find the structural engineer around the corner who is going to provide that. And that is super dangerous. And so, as a leadership group, we decided that as much as it's out of our comfort zone and we're terrified the media is going to do what you just said, is grab that sound clip and put it in backwards to make us look bad. It is a really important thing for us to get comfortable with how to be in front of the media, how to be, not tricked into their sound bites that they're looking for, but provide that balanced voice of authority to keep them from looking elsewhere.
Yeah, thanks for that. Really appreciate you coming on, Emily. So I learned a lot, and it's great to hear what, at least some guidance, for me personally, getting some guidance on how to respond to these types of events. As as someone that works in structural engineering, it's definitely something they don't teach you at school. Like you don't know all these implications in terms of the media. And at least in my profession, or at least in my timeline of being in the profession, that really hasn't happened too much. It's especially like this nationwide. And then, friends and family asking me what happened, and kind of hesitant to respond. And I don't know. I'm not an engineer in Florida, and no one's got any evidence. So for me personally, I appreciate that.
Yeah. Thank you guys so much for having me on here. It was a pleasure to chat with you guys and to be a voice for the structural engineering profession.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, or any questions you may have. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of the key points discussed in today's episode, which is episode number 57, as well as any links to any of the resources, websites, or books mentioned during the episode. Don't forget to subscribe on Apple Podcasts or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.